Today we're having a look at this, and this is a 100 to 220 volt to DC 24 volt 5 amp switch mode power supply. Now this came from China. It was about £11 including shipping. So the first thing I want to do is just take it apart and just have a look at the general quality of it. I mean, I'm not expecting it to be like, you know, an Aztec or a Delta power supply, but I'm expecting at least a reasonable amount of filtering in there and surge protection and all the rest of it. So without further ado, let's take it apart. Do you know, it doesn't sound right unless you say it with an Australian accent. So without further ado, let's take it apart. That sounds better. Don't know why. Very, very odd. Okay, so we've got this little screw here. And oh yeah, I've got that one there. And there's a couple of kind of like clips down this side. And obviously the warranty seal that we don't really give a damn about. Never have, never will. Okay. And there we go. Right, what have we got then? And this is what it looks like with its close off. So here we have the mains coming in. We've got a glass fuse here, a current inrush NTC thermistor there. Got a resistor there. I'm not quite sure what that's for. It might be to discharge the X2 class cap there. We've got a common mode choke there, and the usual 4 diode bridge rectifier there. Going to a, yeah, it looks like a bit of a crappy cap, but yeah, it's only a 10 quid power supply. What do you expect? But interestingly enough, on here, I don't know if you can see this, but it's not made by Rubicon. It's made by Rubicon, which must be a spin-off of Rubicon, obviously. Yes. Over here we've got our switching transistor, which drives the transformer here, and we've got our switch mode controller chip over here. This will be our dual diode, dual Schottky diode, which connects the output of the transformer and then gives us our pulsed DC, which is then smoothed by these capacitors here and then sent to the output. We've got a bit of a feedback loop going on. This is probably a TL431, and that will provide feedback to the switching circuit about what's happening on the output of this side here. Now the reason I bought this power supply is because recently I hacked together a power supply using an RD6006 and a Chinese power supply that I bought a couple of years ago. And you know, while it works, I'd like to build something a little bit safer. And by a little bit safer, this is the job I've done to get this working in a nice compact box. So you sort of see the size of my hand. It's a really nice little compact power supply, unlike the box that you can get for the RD6006 from the official store, which is massive. You know, and that's all very well if you're going to be running, you know, high voltage, high current. But for most people, I mean, I only ever need sort of up to about 19 volts for laptop repair. And other than that, I'm operating at kind of 16.8 volts, 12 volts, 5 volts, and then lower than that. So I don't need anything lumpy. So that 5 amp 24 volt power supply that I bought should be perfect for this. Now all I've really done with this is, you know, this started off life as this power supply here. And what I've done is I've taken off the board off of the front end and I've replaced the pots with much smaller trimmers. Now I didn't really need to do that, but I didn't kind of realise until after I'd finished this project that I didn't really need to do that, because you can actually just leave them on and, you know, the height's fine for this. But this was only really a kind of a proof of concept more than anything else. So we have the controller board here for it, just there. And then underneath we've got the actual power supply board. And it's pretty much exactly as it was, you know, when it was in its original box. However, I've taken the semiconductors off board here and I've taken them up to this heatsink there. So this is an old Xbox 360 heatsink, but it's, you know, it doesn't get above, you know, even without the fan running, it doesn't get above sort of 45 degrees or even running at full pelt for 2 hours. So it's more than, more than lumpy enough for those ICs. But yeah, this is all very well, but it all just felt a bit, I don't know, kind of like a bit Heath Robinson, a bit thrown together, even though it works perfectly fine. And I've been testing this for, a couple of months, and it's behaved absolutely perfectly. Now, this box that I've done is a 3D printed box, designed by myself in Fusion 360. So you've got your little side port down there. That's for your heatsink, and then you've got a little port at the back, and that's just for the cooling fan. But yeah, that was quite fun to design. That was. I think it took me the longest time to get the holes right for this grill, because I just had real difficulty getting it lined up, and I am not an expert in Fusion 360, but I've already designed the next case for this to go in, and I want to run the power supply up and just see how hot it gets at maximum load for an hour. That's how long I kind of like to run them for. So I'm going to plug it into the BK Precision 8540. I'm going to whack it up to its full. I mean, it's 150 watt load, and the power supply's about that, so I should be able to pretty much just max it out. Right, so that's all connected up to the BK Precision load. It's outputting 24.01 volts at 5 amps, which sounds pretty good to me. It's making a slight buzzing noise at the moment, so I'm going to leave this running for an hour to see how hot it gets, and providing it doesn't get too toasty, I can then go ahead and make this power supply. Okay, and it's now an hour later and the power supply hasn't blown up, which is a good sign. And just looking at the thermal camera, we can see that there are some hot spots there. So the hot spots are the switching transistor over here, which is sort of about 120 degrees, and that's about the same for the transformer there, but it survived the test. I'm now going to go ahead and just put that back together again, and then I need to redesign the case that I've done, just so I've got some mounting holes. So I'll probably just use, one mounting hole there, one mounting hole there should be fine for the design that I'm using. So I'm going to go and modify the case. I need to print that out and then put the power supply in and wire it all up. It's the next day now, and the print is done. And this is the box that I've designed here. So you've got the aperture here for the 6006. We've got a little grill on the side there. I think you can just about see there. So that allows for a bit of airflow over the power supply and then throughout the back to where the fan's going to be. We've got once I punch these out, we'll have a hole here for the switch and a hole here for the mains going in. Now what's interesting is that even though I printed out a 2D representation of the bottom of this, these holes are still slightly out of alignment, but I'm not too bothered about that really, because I can just drill a hole in the correct place up here for that one, and this one will be fine down there. And I've kind of messed it up a little bit, so let me show you. If I just put this in here, so this hole down here is lined up, but this hole isn't. And the other potential problem I've got is I haven't got much clearance here to get the wire into these connectors here. So what I'm going to do, I think, is desolder this connector block and then solder the mains input wires and the DC output wires just directly into the holes where that header was. I'm pleased that the power supply tested okay. So I definitely wouldn't run this at its 24 volt, full 5 amp load for any length of time, like days or anything like that. But for what I'm using it for, I think it's going to be absolutely fine. Now, I think I have to unscrew these as well, because the semiconductors need to be loosened off a bit from here. Well, that's torn it. Alright, so here we go. Wow, that is not an awful, there's no wow, there's no paste on that switching transistor. It just goes directly onto there. I think we're going to put a little bit of paste on there. There's a little bit of paste on that one. Okay, that's fine, I guess. Let's move those out the way. And let's put that up there. Okay, that looks pretty good for clearance. Yeah, I mean, got that kind of gap there for clearance. I don't know whether I'd want maybe slightly more, but again, cheap and cheerful power supply, what do you expect? Now I've got to desolder these, and what I might do, I think, is just put a little bit of leaded solder on there, and then I'm going to use my desoldering gun, hopefully, just to suck all the solder out of those. Let's do that. Still using the Jabe, the UD1200, still works very well. I'll just flow the lovely leaded solder into there. Right. Let's see if this works, or whether I'm going to start just doing it manually. Okay, that looks pretty good. Just really getting it up to the right heat. Okay, so looking pretty good. Hopefully I'll just be able to rock that out and remove it. Famous last words. Right, let's see if I can remove that. Oh, well, that was easy. Wonderful. Okay. Oh, what a nice neat job that's made of that. And that's what it looks like afterwards, so I can reuse that if I need to. Put that in the parts bin, I think. I think what I'm also going to do while I'm here is straighten up this dual Schottky diode as well, because it's really pissed. I think we're going to desolder that and yeah, put that in a little bit straighter. So once again, just adding a little bit of leaded onto it to make for easier desoldering. So which is kind of, I could just desolder those two there, couldn't I? There we go. And then hopefully I can just, there we go. And that way, by keeping this leg in here, that one down there, we know that the height's correct. I think I just get away with that. There's a little bit of leg. It's not quite coming all the way through the board, but I don't think it will matter. I think I can just whack some solder on top of that and it will be fine. Just reflow the solder into that joint. Hold it on for a little bit so we know it goes in. And then what I can also do is I could use a multimeter to test it, but that feels like, yeah, that's in pretty well, I think. Let's get a multimeter in on that and just test that those two outer legs have continuity. I'm sure they will. And they do. Already that looks nicer. Right, so now that that's all straightened up and yeah, it looks a lot better, I think I need to solder the mains cable onto the connector here, and also the DC output cable onto the plug for the RD6006. So this is of course the famous RD6006. Absolutely great bit of kit. Absolutely love it. Already got one obviously in my other power supply, and yeah, this came through from China. I think it came through in about a week or something. It was ridiculously fast. So yeah, and I'm going to put this is the thermistor. I'm going to put that in the power supply just so I can monitor its temperature from the front panel of the 6006. But for now I need to pull this off. I need to make sure I get this right. So I think the best thing to do is probably just mark this with plus and minus, because I would be in a world of pain if I screwed that up, wouldn't I? And we'll unplug that and put that out of the way. And then we need to get some wire to go from here to the power supply. It's quite a thick core. I think it's actually like speaker cable or something like that, but again it will be fine for what we're using it for. So I'm just going to strip those out and then cut them and then solder them on. Let's strip those. These are pretty good little cutters. I've had them for a little while. I think they came from AliExpress. I think most of my stuff comes from AliExpress. Let's make sure again we get these the right way around. I would be most upset if I blew up that front end, because it's quite a lot of money. I mean, comparatively, compared to the Chinese power supply that's driving it. Let's put it like that. Okay, so we'll put the stripe can be minus. Now I might have to tin these up first to get them through that hole. Yeah, they are quite thick. Misses. Let's tin that up. I might have to make the hole just a little bit bigger. Not the end of the world by any means. Let's see if we can get those through now. So again, negative side has the stripe, negative side goes on there. Oh, well, I didn't solder that very well, did I? That one's better, so if I can kind of just twist this to get it through, then the other one should just fall into place. God damn it! Let's do that properly. Right. Okay, let's try that. That looks pretty good. Again, minus. Double and triple checking here. Here we go. That one goes into plus. Needs a bit of wiggling. Thinking away, we all need a bit of wiggling. Get in there, you bugger. Get in there. Right, I'm going to make that hole just a little bit larger. See if I can use something like that to do it. Doesn't need to be much larger, just a little bit. There we go. Perfect. And we'll just solder those in there. And that one in there. And that's that bit done. So again, minus there, plus there. And now we can screw that into this bit here. And again, I think tinning those might be the best idea as well. There we go. Now, let's use the right screwdriver for this. Okay, so minus goes in there, plus goes in there. There we go. Looks pretty darn good. Do that up. I think I prefer having the connectors or these wires soldered into the board rather than going into the cheap crappy screw terminals. Oh, something's gone a bit wrong there. Let's see if we can correct that as well. It's not quite all the way in the board, so let's correct that and just solder that in. It doesn't really matter, but it does look better if it's correct. That looks good. Just chop that off. Perfect. So that is the connector for the front end done. The front end will kind of sit here and the connector will go into there. Brilliant. Okay, now to do the mains side of things. I have spoken to my friend Paul about the mains side of things because I wasn't sure whether I strictly speaking needed an earth for this, but we kind of went over the power supply, and these capacitors here are kind of reference to frame ground, so we thought it's probably a good idea to have an earth on that. There's no sort of exposed metal once the top's on, you know, nothing will actually be exposed, but it certainly can't hurt to earth it properly. I am not a trained electrician, and he is, which is why I speak to him about these things. Okay, I think what we want to do with these is we'll tin these up as well. This is a plug, there's a lead rather, that already has a plug on it. Trying to make my life a little bit easier. There we go. I think this is my first lockdown video. I've been waiting for stuff to turn up from China, you see. I haven't just been completely lazy. I mean, I have partially been completely lazy, but can you be partially completely lazy? Well, I've been a little bit lazy anyway, but I have been waiting for this stuff to turn up as well. Okay, so we've got our AC in and frame ground. So live is brown and neutral is blue. The way I kind of remember that is in a plug, My dad always taught me blue to the left, brown to the right. So blue on the left hand side is a neutral because it doesn't go through the fuse, and then brown on the right hand side goes to the fuse, so it's the live. And that's how I remember it. That can go in there, that can go in there, that can go in there. Wonderful. Wonderful and marvellous. I nearly made a classic mistake there. See if you can spot my deliberate mistake. I have to put the wire through the back here. And I suppose if I'm doing it like that, I also need to dig out the switch, because the live is going to be switched in there as well. Right, well, as I can't actually find what I've done with the toggle switch, I think I'm just going to not have a switch in this one. The other one hasn't got a switch in it either, because, you know, when I switch my workbench on and off, I switch everything on it on and off, and it's not something I kind of leave running unless I'm working on something or, you know, fixing something or whatever. So I think I'm just going to take that straight through and just put that straight onto the board. Now we need to kind of get this mains cable all the way through, because I've got to wire it up to the power supply, and then I've got to put the power supply back together again. So we'll just push that all the way through there. Now this case is printed in PLA, and ideally, really, because of the way PLA deals with heat, you know, it's not really suitable for stuff that gets reasonably hot. But I don't have ABS, and neither of my printers can really print in ABS because they're both open frame. So PLA it is. Like I say, I'm going to have the temperature sensor. I'm going to bond that onto the power supply, onto the chassis of it, just so I can kind of keep an eye on it, but I'm not too worried about that. Right, let's put those on then. So brown is live, neutral is the blue, and ground really, I suppose it would have been easier to do these one by one. There we go, that should be okay. Glad I remembered to do that before I put it all back together again. That's the main side of things connected up. We'll clip those down. Okay, so neutral, frame, ground, live. Now I can put the power supply back together, and I'm going to refresh, well, not even refresh, I'm going to put some heatsink paste on that transistor there. I mean, it seems kind of weird that they neglected the paste on that, because they pasted the diode. So that's yeah, a little bit odd that. Okay, that's got its paste on. May as well refresh the paste for that one there. Can't hurt, can it? Again, we only need a thin layer of paste. Less is more where heatsink paste is concerned. I've not put it in the, there's little guide rails there, and I've not put it in there. Right. That won't help, will it? A rookie mistake. We'll loosen that one off again. Okay. And we need to make sure that the circuit board is within those guide rails, which it now is. So I don't know whether you can see that, but yeah, that looks good to me. And we'll put one screw in that corner just to kind of hold it in place. nice and tight. We'll do this one nice and tight as well. There we go. Right, that is looking pretty good actually. Yeah, I'm quite happy with that. Now we can put its little lid on. I can remember how to do this. Oh, it's probably like that, isn't it? Yeah. Wonderful. Just put that screw in there. And the final one on the back end here. Great, that's done. I've got to decide where the best place to put this sensor here is. Straighten that up, there we go. I think when I measured this before, I think the whole frame got reasonably warm, but I'm really only looking kind of for an idea of how hot this thing is. And I could probably, what if I kind of put it on the end there and then just use some thermal adhesive just to bond it on maybe. I'm going to put a bit of glue on there. And then we can just smush that into it like that. And we'll take that out there. Smush a little bit more on there as well. Like so. It's got quite a distinctive smell to it, this has. Couldn't honestly tell you what it was. It's almost like a sweet sort of smell. Very interesting. Well, I mean, if you're into that sort of thing, obviously. Definitely want to make sure this doesn't go anywhere, so chuck a load of it on there. And when this sets, it sets like silicone rubber, but obviously it's thermally conductive. Excellent stuff. Right, well, I'm going to cut while that's setting, and then we'll come back to that in a bit. Okay, so now that thermal adhesive is set, I need to mark out the hole that I need to cut out because of, well, because they're not in the right place, basically. So let's go ahead and let's pull this back through there, like so, because we need to get this over to kind of there. There we go. And what I'm going to do is once I put this together, I'm going to put a cable tie around here just to give it a bit of strain relief. But for the moment, I'm going to mark off where the hole should be at the top there, and make a hole. So that should be fine. I'm also going to 3D print just a couple of feet like I've got on the other one. I've got a printer which is just loaded with TPU filament at the moment, so it's quite good for making kind of rubbery type feet. So we need to move this out of the way a little bit. And now we need to drill the hole. And I've got to make sure I don't drill through my mat, so I'm going to have to hold it up a little bit. Well, the hole wasn't too far off, but it was weird that it came out fine in the test print I did. And now I should be able to mount it in there. Yeah, that looks good. So let me go and get a couple of bolts. And to mount it, I'm going to use some nylon nuts and bolts. So something like that. They're non-conductive, and I could just crop them off with just a pair of cutters. Nice and easy. So we'll just get a set of them there. And another one of those. And another one of those. Let's screw that in. I think they'll be the right sort of size. Let's double check that, shall we? Yep. Not wrong with them. This could be fun because there's not an awful lot of space to work with to get these in. Right, let's get a screwdriver out and see if we can just kind of use that to push it through. There we go. I'm going to put that on the bottom. And at the moment I haven't put a fan in this one because I don't have a spare 50mm fan, but I will put that in at a later date. And now we need to put that one there. It's a little bit pissed, but that's all right. Put this one down there. Like so. Bloody well came out. Right, let's do that again. And let's put the screwdriver on there just to hold it in. So the fact they stick out down the bottom won't really matter once I put the feet on. Great, so one there. One there. And that is the power supply screwed in. Now we need to put the front end in, which should literally just clip in. And what we'll do is we'll get this we'll get the sensor cable tucked through there first as well. And also with these power supplies you can actually increase the output voltage, so I might be able to get it up to sort of 27 volts or something like that, which might be quite nice. Just give it a little bit of extra overhead. Oh, perfect. Okay, and let's now plug this in. Now, between you and me, I have a little secret, and that's that someone didn't measure the wire properly, so that when I went to plug it in, it didn't actually reach, which is great. So I'm going to have them fired, basically. I have extended the leads now, and that should be pretty good to go. So we just plug that into there. I'm going to just cable tie up the sensor and just tuck that out of the way. Let's cable tie this up. Right, well now I guess it's the moment of truth really, isn't it? We have a power light and we have boot. Great, okay, so at the moment the input is showing at 24.7 volts. So I'm going to go ahead and increase that pot on the board, on the power supply, I don't know what way around that is, but there we go, and we're now showing 27.68 volts. So that's brilliant. The only additional thing, like I say, I'm going to put in when I get one is just another fan here. But again, I'm not going to be running this anywhere near its full wattage at all. You know, I very rarely even use 19 volts, let alone anything higher than that. And again, 5 amps is normally my total limit. This will probably be operating at sort of 30 or 40 watts most of the time anyway. So again, that's not something I'm going to get too excited about getting. This thing here does actually have cooling on it. Obviously that doesn't really help the power supply down here. But the next thing I think I'm going to do is just plug it into a BK Precision electronic load. And I'm just going to run not a full pelt test, but probably like a 75 watt test on it, just to see if it works okay. But I just think that's a really nice way of just making a cheap and cheerful, really a full featured power supply. It's just a really nice way of doing it. Only time will tell about how long this thing will last for, but the construction seems okay. If it blows up, I will tell you in a future video. I'm just going to unplug it and then put a cable tie round this mains lead. It's actually held in there quite well anyway because it's a friction fit on the PLA case, but just a little bit of extra. It can't hurt, can it? Just a little bit. You see, it doesn't really move too much, and yeah, this isn't going to be moving around anyway. Let's get down there and cut it off. It's got so much space in it. Of course, in the old one, I had the Xbox 360 heatsink there providing all the cooling, but you know, this will be even better, really. It'll probably get a little bit warmer. I need to keep an eye on that, but I'll be doing that with the temperature sensor on the front. Let's plug it in and just see what temperature it's running at the moment. Right, so 28C it reckons, which is about right. It's quite warm in here today. It's yeah, a very, very warm day, probably one of the warmest days we've had this year, although apparently it's going to be very cold tomorrow. That is the end of the weather forecast. If you've enjoyed watching me create a nice compact RD6006 based power supply, please like and subscribe. If you're annoyed at the person who couldn't measure wires properly to connect the front panel to the power supply, don't like and subscribe. Thank you for watching. Goodbye.